All right, here's a little help for number 26. It's a tricky little problem. And some things are in there that I haven't addressed directly in class. And thanks for those who just used all the online tutorials and videos and other things that allowed you to finish this. So it was pretty nice to see a lot of you successfully get to this one, even though I hadn't really addressed it. 26 has two parts to it. One, there's a dollar price per ticket, and then how many tickets were sold, two different prices and tickets sold, to create a demand curve. And we've done that before, where you plot the points and you do this demand curve. But what we haven't really talked about is how to do revenue. And the formula for revenue is number of units times the price. So I have a little formula there that says R of X equals X times P. Well, that P, it's a funny thing. Demand is a formula for figuring out what the price of things is, because depending on what price you set for a particular object, that will also determine how many will be sold. So demand curve really can sometimes be called a price curve. Price demand is actually what we call it, hyphen, price hyphen demand. So that little P there actually stands for a price demand equation that we're going to put in there. Cost, I think you can probably interpret that one as 0.1 or 10 cents per unit. And so that's 0.1x, and then plus $85,000 in fixed costs that you see there. And then profit, which I haven't mentioned specifically, but you could have read about, is that it's revenue minus cost. Profit is what you make above. You pull in a lot of money as revenue, but you have to take out your costs to figure out what you take home as profit. So revenue minus cost is profit. All right, so if I go to the next step here, so that P I was telling you about, that demand curve, that's what I'm going to show you in a minute. And then the revenue or the cost function, which is all pretty clear. There's profit is revenue minus cost, all the things I mentioned. Now I'm going to move to getting that demand curve. So here's how this goes. If you plot that data, so watch carefully. I'm going to put in the 4 and 5 and the 48,000 and the 42,000 that were given and put them on a little scale. Now today I'm going to put the price along the y-axis, so it's our output. And then on the bottom, I'm putting the number of units sold, which is kind of common. X units would go on the x-axis, and price P would go on the y-axis. And then just make sure you know that I got those from the reading the problem and how many units were sold. And I've not drawn it really to scale, but I've drawn it so that they're relative. 42,000 is below 48,000, and 4 is below 5, etc. Then if I keep going and connect those two, the line that connects those two is my demand curve. Now, funny word, because it's not really curved, it's a line, but often it can be curved. In this particular case, it's not. And what I want is the slope of it, and ultimately the equation of that line. And the slope is rise over run. 5 minus 4 would give you the rise, and 40, and then you have to do it in the right order. 42,000 minus 48,000 would give you the run, and y2 minus y1 over x2 minus x1 if you like it that way. Those numbers give you 1 over negative 4,000, which is negative 0.00025. So that's our slope of that line, that demand curve. Now, plug that slope in with one of our points. I'm going to use 48,004, the lower right-hand point. And remember, y is the up and down vertical. That's going to be our, that y1 goes in as 4. And then y2 is, or the x1 is 48,000. Okay, so I've got those placed in their spot. Slope is in its spot. That's going to be our demand curve. I just need to solve for P, maybe do a little simplifying. And P is in price, right? Remember, that's our price on the left-hand vertical column instead of a y. So here goes, negative 0.0025, and then I distribute that times 48,000, and I get 12. I add the 4 to both sides, as you can see right there. And if I simplify that just a wee bit, negative 0.00025x plus 16 is our demand curve, our P demand curve. If I take that back to the very beginning of this particular problem, so I'm going to skip back just a little bit, skip. What I can do is fill in this equation right here, and that'll be my profit function that goes in that box. So here, let's do revenue. Revenue then, I'm going to do a little different color. Let's go red, so I can fill this in properly. Red equals x times this brand new price function that I just came up with. And so if you remember, I ended up with, let's go over to the right here, one more time. Here it is, 0.00025 plus 16, okay? So that's what we're going to plug in there. And I can put it right here. Negative 0.00025. And that's x plus 16. That is my x times p, my price function. That's going to give me revenue. And then my cost function, well, I already got that. So when I'm doing revenue minus cost, I just need to put in those complete equations, and so I'll do profit is, the x times, now you're welcome to distribute that x up top there, so you can call it negative 0.00025x squared, since you distribute that, plus 16x, if you like. Okay, that's going to be my revenue function, minus that whole cost function, which I'm not going to write because it just fits right in there. We've got it. Let's just put an arrow. That's all you need to write in there for profit. Then you would graph it, your favorite graph or Desmos, graphing calculator, whatever you like. And then the last part, it does ask you for p prime, the derivative of it. But it's a pretty nice little derivative. I'll let you work that out and plug in any values. But I think this is the part that was less obvious and needed some help for you to get to your results. Let me know how that goes.